Hello everyone, this is TSC Zindabad and today we are going to discuss the daily challenge of Leetcode, which is set mismatch. So the problem statement says that you have a set of integers s which originally contains all numbers from 1 to n. Unfortunately, due to some error, one of the number in s got duplicated to another number in the set, which results in repetition of one of the number and loss of another number. You are given an integer array nums representing the data status of the set after the error. Find the number that occurs twice and the number that is missing and return them in the form of an array. Okay, so this is the problem statement that has been given to me. So probably I'll have an array, something like 1, 2, 2, 4, right? So this is the nums array that I have. In this array, I'll have two things. First one is I'll have a duplicate number. There will be just one duplicate number, right? And the second thing is one number is missing, right? So we have one duplicate number and we have one number which is missing, and we need to figure these out and we need to return them in the form of an array. This is a super easy question. So now let's jump into the approach. Okay, so talking about the approach, the first thing that comes into my mind is when I look at this problem statement, wherein I have the nums array, something like 1, 2, 2, 4, right? So what I can understand is that I need to figure out the duplicate number and the missing number. So how can I do that? I can do that if considering a brute force solution, right? So if what I do is I iterate over my nums array, right? I figure out the count of the element, which is 2, and the count of the element, which is 0. So the count of the element, which is 2, it represents that this number is a duplicate. As it is mentioned in the question, we will be having only one duplicate, right? So this shall work. And count of the element equal to 0 represents that this element is not present in the array. As we know, it is given in the question, we'll have the elements from 1 to n, and n is also inclusive. And here n is the size of the array. So here the num size is 4. So I know that I should have something like 1, 2, 3, 4. But when I look at this nums array, I see that I do not have something like a 3, and 2 has a frequency that is equal to 2. So that means it is the duplicate, and as 3 is not present, so it will have its count equal to 0. So we can say this is the element which is not present. 2 is the element which is the duplicate and 3 is the element which is not present, and we'll simply return something like 2, 3. So what we can do is for basically applying this approach in terms of code. Okay, so to code this approach up, what we'll do is we'll run two nested for loops, right? The first for loop will go from I is equals to 0 to n, and n here is inclusive in nature, right? We can have something like, suppose int count. Let's initialize it to 0. Herein we'll have another for loop that will be running from 0 to n, right? And here n is not inclusive. I'm sorry, there is a very little change we need to make. The first for loop will be running from I is equals to 1 to n. This is because it is given in the question that the set has the elements from 1 to n. It should probably have these, right? So now we have the first for loop running from I is equals to 1 to n. We have initialized a count, and then we are running another loop nested inside the first for loop from j is equal to 0 to n. This is basically for traversing the given array, right? And the first loop that we had was to check for the count of the number that should originally be there, right? If our goal is to have something like we have nums, right? And it should act as a set. And as we know that set should have a frequency of one for every element because it stores only unique elements. So we should have had something like 1, 2, 3, 4, right? So basically this for loop is scattering that are these all present or not, and it is somehow computing the count corresponding to each one of them. And here we can, after this second for loop, we can simply have an if statement that if nums of j is equal to I, in that case, you just increment the count. We'll come out of this for loop. And after that, what we can do is we can check. We can have two checks that if count is equal to 2, that means I have found my duplicate. So make this the duplicate. That means you can simply give it the value of I, or you can have something like if count is equal to 0. That means this element that should have originally been there. But as we know that there was some error in the set as it is given in the question, it is not. So this is missing. And we'll initialize with I. And then we can simply return this in the terms of duplicate, comma, missing. So this is the pseudocode. Now let's talk about the time and space complexity corresponding to it. As you can clearly see, we have two for loops, right? And in the worst case scenario, it will be going for all the elements. So we have a time complexity of O of n square. And here, as we are not maintaining any extra data structure for maintaining a count, we just have one variable. So this space complexity boils down to O of 1. So looking at this, we understand that the time complexity is too high and we can optimize it further. So now let's talk about how we can optimize it. So now let's talk about a better approach. Initially, what we saw had a time complexity of O of n square and a space complexity of O of 1. Now let's try bringing our time complexity to something like a linear, right? So this is our goal. I know I have the nums array, right? And in my nums array, I have these elements that are there. And what should have been originally, if there was no error, it should have been something like 1, 2, 3, 4. But because of the error, we are getting 2 twice and 3 is missing, right? So here, as I first talked about this question, I was talking about something related to frequency. So whenever we talk about frequency, the first thing that comes into our head is the map or the set data structure. Basically, the set data structure is used for uniqueness. I mean, we can figure out that if that element is just occurring once in my nums array and if it is occurring twice, we can consider it as the duplicate, right? And we can again run another for loop that can be from I is equals to 1 to n being inclusive, and we can check that if it is present in the set or not. And supposedly, if it was not present in the set, we can use the s dot find function. It takes a time complexity of O of 1, right? So for example, it was not present in my set. In that case, I can consider it to be my missing number and we can simply return it. This approach will take a time complexity of O of n and a space complexity of O of n. Why is the space complexity? Because we'll be either using a data structure which is a set or a map. So let's quickly code this up, then we'll have a quick dry run, and then we'll talk about the best approach for this problem. So this is the problem that has been given to me, right? So what I'll do is, let's quickly have an unordered set, right, with int type. Now what I'll say is, I'll say like, let's run a loop on all the elements that are present in my nums array, right? I'll say that if s dot find nums of I is not equal to s dot end, which means whichever nums of I you are trying to put in my set, it already exists. In that case, what you can do is we can like have something like int missing and duplicate here. So I'll say that is a duplicate because it was already there in my set and you're trying to again put it. So I'll say duplicate is equals to nums of I, right? And supposedly it will, if this is not done, that means then what we have to do is we need to simply insert it into our set. So after that, we have figured out how we will be figuring out the duplicate. Now let's talk about how we will be handling the case for missing. What I'll do is I'll simply run a for loop for int I is equals to 1 till I is less than equal to nums dot size. And what I'll say is I'll say that if s dot find I is equal to s dot end. That means for that particular I value, you could not find it in my set. That means if it is not in the set, it was not there in my nums. So it is the missing value. So we will say missing is equals to nums, missing is equals to I. And then we can simply return duplicate, comma, missing. I think we're good to go. Let's quickly run and submit it. It's running fine. Let's submit it. Yes, it is working fine. Now let's quickly have a dry run and then let's talk about the most optimal solution. So this was the code that we were just working with, right? And let us suppose we had the nums array as 1, 2, 2, 4, right? So here what will happen is we'll have a set something like S, the first for loop, and we have the, obviously we have the missing and the duplicate variables initialized, right? Then my first for loop starts traversing the nums array, right? So it sees that is it present, it says no, we'll add 1. It goes to 2, it will see that is it present, no added. As soon as it comes to this 2, we see that it is already there. So as it is already there, so we'll like whatever is the value at nums of I, we'll put that into the duplicate, that is 2, right? And then it moves forward to the next index. We get a 4 and we see that no, it is not added into the set, so just add it. We exhaust this loop, we go into the next loop. As it was given in the question that we have to have I to n elements in that set, n being inclusive. So what I'll do is I'll simply have the I value starting from 1 and I'll check that is my set having this value. So I'll say yeah, set has 1. So I'll increment the value of I, it becomes 2. It is present in the set, it becomes 3. Now 3 is not present in the set, right? So we'll simply make missing equals to 3 and after that what we'll do is we'll increment it to 4 because it is less than equal to, right, for the number of nums dot size, and the nums had 4 number of elements, 4 sizes. So that is why it goes to the set again, it checks if 4 is there. So after it is completed, we have the value of missing and duplicate and that is returned. Talking about the time complexity, it is O of n because in each case we are having just a linear traversal. As we have used the unordered set, the s dot find and s dot insert functions are of O of 1 and the space complexity is O of n because we are using a set. We understand that for figuring out the missing and duplicate, because it entirely depends upon the nums array that has been given to you, right? The missing or duplicate can be at any index. So at least we would require one traversal. So we cannot boil the time complexity further down. It will remain as it is, but maybe we can do something with the space complexity. So now let's talk about the most optimal solution. Okay, so now let's talk about the most optimal solution. So in the case of most optimal solution, I'll be using the concept of XOR. Now, XOR is a bitwise function. What happens is, if you have the same bit, that means if you have 0, 0 or 1, 1, then you'll get 0 as the answer. Else, if you have the different bits, that means you have something like 0, 1 or 1, 0, then you'll get 1 as the answer. I'll be using this concept to solve the problem. Now, what I'll do is I'll divide my approach into different steps. The first step will be to initialize the variables. We'll be talking about in detail that which variables are we going to initialize, how are we going to do it, and how did I come up with this thought process. Just stick with me for a while and you'll understand all of it. The second step will be to identify the rightmost set bit. The third step will be to separate numbers with and without the set bit. The fourth step that I'll be doing is I'll take the XOR of the numbers based on the set bit, and then finally what I'll do is I'll say identify the error number. So when I say identify the error number, here I mean both. That means identify me a combination of both the missing and the duplicate number. So how will I be doing this is basically I'll be using the concept of XOR, right? And following all these steps. Now, first I'll code this approach, then we'll have a dry run. And while having the dry run, I'll explain you the concept of how and why things are done this way. So now let's jump into coding. Okay, so this was the problem statement. So what I'll do is I'll quickly create certain variables, right? So let's have variable named as XOR all, and let's initialize it to 0, and XOR array, right? So now what I'll do is basically this XOR all is for me to find out that what is the XOR value if my set had not had an error. That means what I'll do is I'll simply iterate over 1 till I is less than equal to n, I plus plus, and I'll say XOR or is taken XOR with the I value, right? So what happens here is I get the XOR value corresponding to the number that would have been there in the set if there was no error occurred, right? So here, after that, what I'll do is I'll have another for loop because I know the error has occurred, right? So I need to understand that how that error is affecting in terms of the XOR, right? So now I'll iterate over my nums array, right? And I'll say XOR array, you store the value of what is the current XOR, right? Because we know that there has been an error, right? This for loop is scattering to the XOR value if no error was to occur, if we were getting the right answer. That means the set was storing 1, 2, 3, 4, right? And this other for loop is storing if the array has had the error, right? Because as it is mentioned, we will have the error. And because of this, there is a repetition of one element and loss of another. So using these two variables, that is XOR all and XOR array, I'll be computing how we can figure out those missing values. Then what I'll do is I'll have another variable, let's call it XOR result, which is nothing. It is just taking the XOR of both these values, right? So we'll quickly take the XOR of both these values. Then after taking the XOR of both these values, the next step, as I had mentioned, was to figure out the rightmost set bit, right? So for that, what I'll do is I'll create something like, let's call it rightmost set bit, right? And here, what I'll do is I'll take the 2's complement for XOR result. So XOR result, and we'll take and minus XOR result. This is the representation for taking 2's complement, right? When I talk about 2's complement, it is about flipping zeros into ones and ones into zeros and then adding 1 into the result. Let's create another variable, that is XOR set. Let's initialize it to 0. Int XOR not set, and let's also initialize that to 0. Now basically these will be storing my missing and the duplicate values. After this, what I'll do is I'll run a for loop for int I is equals to 1, I is less than equal to n I plus plus, and I'll say that if I, and if we take an and bitwise and with the rightmost set bit, if the and is there, that means we're getting a true value, that means we're getting a 1. In that case, take an XOR of XOR set with the value of I, right? And if this is not happening, we'll have a else statement. We'll say take an XOR with XOR not set and the I value. After this, I'll run another for loop, right? This for loop will run from I is equals to 1 till I is equals to 0 till n, basically on the nums array, right? So I'm saying we have something like auto I nums, and here what I'll do is I'll say that if, because okay, we took I here, so let's consider it as num here, right? So if num, and if I take a bitwise and of num with the rightmost set bit, if it is true, right? In that case, what you have to do is you have to have the XOR set. I'll quickly copy paste it. XOR set have an XOR with the num, else there would be an XOR between the XOR not set and num, right? So as soon as we are done with this, what finally now we need to return is, we'll say run another for loop, that is int num in the nums array, right? Iterating over the nums array. I'll say if num is equal to XOR set at any point of time, right? So in that case, what you'll do is you'll simply return the XOR set comma XOR not set, else you'll return the opposite of it, that is XOR not set comes here and XOR set comes here. So let's quickly run and see if it is working fine. Then we'll have a dry run and we'll talk about its time and space complexity also. And yes, it is working fine. I'll quickly copy paste the code and then we can discuss further. Okay, so this was the code that we were working on, right? And assuming that my nums had something like 1, 2, 2, 1, right? So here what happens is, first of all, I'll have something like XOR all, that is initialized to 0, and XOR ARR, that is also initialized to 0. Then I'm running a for loop that is from I is equals to 1, I is less than equal to n, I plus plus. So my XOR all becomes XOR all, that is 1, XOR with 2, XOR with 3, XOR with 4. Why? Because n's value in this case is 4. As soon as we do the XOR of all of it, right, we'll get something like a 5. Sorry, we'll get 4, right? How are we getting 4? We get 4 because XOR of 1 and 2 is 3. So these guys cancel out and then we get a 4. Talking now, as soon as we've completed this for loop, we go to the next one. Here, we'll be taking the XOR of all the values which are present in my nums, right? So XOR all as 1, XOR with 2, XOR with 2, XOR with 4, right? Here we have a 4 on the third index, right? So these two cancel out. When we have an XOR of 1 and 5, 1 and 4, we get a value that's 5. So we have completed till here. We create a variable that is XOR result. So basically this XOR result is the XOR of XOR OR and XOR ARR, right? So 4 XOR 5 comes out to be 1. Now how is this, guys? See, it is very simple. These are the decimal numbers, right? Converted into binary. If you convert 4 into binary, you have something like 100. This is 4 and this is for base 10. That is, it is decimal here. And this one here is the binary representation of it. So basically, you do not have to explicitly convert it into binary and then do it. There is no need. You can directly use the XOR. It will handle this at the back end. I'm just telling you how it is computing this value. Okay. So talking about 5, the binary representation is something like 101, right? And when you take an XOR, initially I told you that if you have these same bits, that means if you have 0, 0 or 1, 1, you get the result as 0. But if you have the different bits, right? So different bits means that you have 0, 1 or 1, 0. In that case, you'll get a 1. So here, as you see, we have 0, 1, so we get a 1. 0, 0 same bits will get a 0. 1, 1 same bits will get a 0. So finally, we get an answer as 1. So we've completed till here. Now, what happens is we check that is the rightmost set bit, right? So that means is the rightmost bit set or not, right? So herein what I am doing, I'm taking the 2's complement, right? So whenever this whole part is 2's complement. So what is 2's complement? 2's complement is whatever is your binary number. For example, XOR result, we know this is the XOR result that we have obtained, right? So 2's complement is the first step in it is flip zeros to ones and ones to zeros. So I'll flip these, so I'll get something like 110, right? After that, the second step is add 1. So then I'll have something like 111, right? So after that, we'll figure out the rightmost set bit, right? So once I figure out the rightmost set bit, I understand that the rightmost set bit will give me 1, right? So now I'll initialize these two, that is XOR set in equal to 0, XOR not set is equals to 0. Now I'll run this for loop here, right? I am scrolling a bit down so that we have more space. Yeah. So now I'll say, let's run this loop, I is equals to 1, right? So I'll check that is I, if the AND bitwise AND of 1 and the rightmost set bit that was 1, is it also giving me 1? Then I'll come here. So I see that yes, when 1 is represented, this is the decimal form. When it is represented in binary, right, that is something like this 100. And if you do the and with 001, which was the final rightmost set bit, this was the rightmost set bit, then it gives a true answer. So for XOR set, you will XOR it with I. So after you XOR it with I, you will get something like a 1, right? After that, I value gets incremented to 2. 2 is represented as 0, 1, 0. Now, when you AND it, it will not give you 1. So you go to the else statement, and here your XOR not set as 2 in it, right? Because it is when you take an XOR with the value, you'll get a 2, right? Then I value gets incremented to 3. 3 is represented as 0, 1, 1. And when you take an AND with rightmost set bit, so as we know, 3 is represented as 0, 1, 1, right? So when you take its XOR, when you take its AND, bitwise AND with the rightmost bit, right? So that is something like 0, 1, 1, and you had 0, 0, 1. So if you take the AND of it, 1, 1 will give you 1, 0, 0. So it is giving the value as 1. So you'll put it in the XOR set. So XOR set will have XOR with 3. So 1 XOR 3. Then it gets incremented. I becomes 4. 4 is represented as 1, 0, 0. So when you do that, you will see 1, 0, 0. When add a bitwise and with 0, 0, 1, you will get 0, 0. So it will have, what will it have? XOR with XOR not set value. So that will make it 4. So after this, we'll come to this for loop, right? And now we'll be checking for the num values. So I'll quickly erase these. So now my I value supposedly is 0. So nums of I, as you know that the nums vector was something like 1, 2 to 4, right? So we have for I is equals to 0, nums of I is 1. So its decimal is obviously 1, binary makes it 1, 0, 0, 0, 1, right? So when you do it, do the XOR of this number with the rightmost, you will get 1 and that gets added into your XOR set. So 1 comes here. Then you go to I is equals to 1 as I is incremented. So nums of I, that is 2. Its binary representation is 0, 1, 0. And now when you have, when you do 0, 1, 0, when you AND this with 0, 0, 1, you will get 0, 0 as the answer. So the if statement does not hold true, you'll go to the else statement and add 2 here. Similarly, I gets incremented and on nums 2, you get again a 2, right? So binary representation of 2 is 0, 1, 0. Again, when it is, when as you see again, when it is and bitwise and with 0, 0, 1, which was the rightmost bit, it gives 0, 0. So it again gets XORed with the XOR not set. Then for I is equals to 3, we have 4. So 4 is represented as 1, 0, 0. So 1, 0, 0 is added with 0, 0, 1. You get 0, 0. So it comes here, right? So after this, the final value of XOR set here becomes 3. And here 2 and 2 cancels, 4 and 4 cancels, we get a 2. So we see that this is the missing value, right? And this is the duplicate. And then we simply return it accordingly, right? That if num is equal to XOR set, right? What we are doing is, because I have to return it in the order duplicate comma missing, so this is how we return. I hope the diagram was clear. Talking about the time complexity, as you can see in the code which we just wrote, that at max we have to figure out and we have to traverse almost all the elements, may it be for figuring out the XOR or for us to understand the XOR of the array, right? So we have to traverse all the elements. But here, as I'm just working with variables and I'm not using any particular data structure, my space complexity boils down to O of 1. This is the most optimal solution. Thank you so much for viewing the video till the end. If you have any comments or suggestions, please put it down in the comment section and we can discuss it further. Thank you so much. Please like, share and subscribe.